Today we're going to learn about representing proportional relationships. When we represent proportional relationships, we can actually represent it in three different ways. You have been provided with a foldable. I want you to fold it all the way just to the title, and then you're going to fold it down like that. The three ways that you can represent proportional relationships is through tables, an equation. An equation is an indicator when it has an equal sign, y equals kx, or through graphs. The next step that I want you to do is I want you to kind of flip it upside down, and we're going to cut our paper just to the fold. So we have three flaps that it breaks up our tables, our equation, and our graphs just to the fold. All right? So the next step we're going to discuss. So with the table, in order for it to be a proportional relationship, you have to have a constant number. All right? A constant number is sort of like having 3 apples at one table, 3 apples at another table, and 3 apples at another table. That constant is that 3 apples. If it is not constant, we call it variable. I know, guys, that you think a variable is, well, we know is also a letter that's a placeholder, like X and Y. But in this case, a variable is a number that varies when we receive a table with different numbers. So the first thing is we're going to discuss what a proportional relationship is when we're utilizing the table. A proportional relationship between two quantities is in a relationship in which the ratio, we know a ratio, it looks like a fraction, it's a comparison of two numbers, of one quantity to the other quantity is constant. Constant means that we have to come out with the same number every time. We want to know, is this relationship in the table proportional and why? When we look at a table, the top row is always X and the bottom row is always Y. To find out if it's constant, you're going to use the equation K equals Y over X. All right? So let's see, is this constant? We're going to do our Y over X. So in this case, 60 over 1. 60 divided by 1 is 60. The next row or column, 120 over 2. 120 divided by 2 is 60. The next, 180 over 3, which is 60, and 240 over 4, which is 60. Is the relationship in the table proportional? Yes, because we have a constant of 60 over 1 as a ratio, or just 60. All right? So that is when we talk about tables. Let's talk about an equation. With equations, a proportional relationship can be written as an equation in the form of y equals k, which is our constant, times x, where k represents the constant of proportionality, okay? In order for an equation to be proportional or have a proportional relationship, it must be identified as a constant. That means that I can't have anything after the x. The reason is that it would be plus 0, where we're starting, if we were going to graph it, at the origin, or 0, 0. So when I look at these equations, I need to decide, do they represent a proportional relationship? When I look at y equals kx, I can see that y equals 12x, they look the same. So that means I can circle here, all right? And my constant, or my k, in this equation is 12. When I look at the next one, it does not represent a proportional relationship because it's plus 1. Remember, it has to look exactly like y equals kx. They have added something in, so this is not. The next one, it is y equals 0.75x, where my constant is 0.75. The last one, this as well looks exactly like the y equals kx, so my constant is 1 over 4. Okay? This is how we find, looking at an equation, if there is a proportional relationship within an equation. Our last one is graphs. In order for a graph to be proportional, there's 2 criteria that must be met. The first is that the graph of proportional relationship is always a straight line. That is 1. And the second, that the line goes through the origin. And the origin is 0, 0. If there's only one and not the other, then it is not a proportional relationship. Let's look at this example of the graph. Yes, this is a straight line, so it meets 1. And the second, yes, it goes through the origin, so it meets both criteria. So this is a proportional relationship because it goes through the origin. Okay? All right, let's look at example 4 and let's try to figure this out. They gave me an empty graph, empty table. So I want to do 3 things. I want to fill in the table, find out what my constant is, write an equation, and then lastly, graph it. Okay? So Dakota earns $8 an hour at his part-time job. So we need to do our X and our Y. Our X is the hours that Dakota works. And the Y is the amount of money Dakota earns. If he works 1 hour, we know he earns $8. If he works 2 hours, we multiply 8 times 2, he will receive $16. If he works 3 hours, he will receive $24, 4 hours, $32, and 5 hours, $40. All right, so in order to find our constant, remember it's K equals Y over X for the ratio. We know 8 over 1 is 8. 16 over 2 is 8. 24 over 3 is 8. 32 over 4 is 8. And 40 over 5 is 8. So my constant is 8. My ratio is 8 over 1. So when I write my equation, Y equals, my constant is the 8x. Okay? We are now going to graph it. I know that my X, in order for me to label, we said was hours. Okay? So I can work 1, 2, 3, 4, 5, 6, 7. And then my Y is the amount of money earned. So I'm just going to turn this like this and write the word earns with a $sign. And I'm going to say the first line is 8, then 16, 24, 32, 48, 56, 64. 1 hour 8, 2 hours 16, 3 hours, and so on. I'm going to take a ruler and I'm going to draw my straight line. I know this is a proportional relationship because the constant is 8. And I know it also by looking at the graph, it's constant or has a proportional relationship because it's a straight line and it goes through the origin, 0, 0. All right, let's look at the very last example. This they've provided me just with the graph filled out. So I know my X is feet and my Y is inches. So for every 2 feet, I know it's 24. For every 4 feet, it's 48 inches. So I think I can fill in the blanks. I know 24 over 2 is 12, and 48 over 4 is 12. So I'm assuming that it would be for every 1 foot, it's 12 inches. For every 3 feet, 36. And for every 4, for every 5, it's 60, okay? So 12 over 1 is my ratio. My constant is 12. 36 over 3 is 12, and 60 over 5. Remember, it's k equals y over x. For my equation, I'm just going to place my constant, replace that into the equation, so it's y equals 12x. All right, so I hope that you understand how we can represent proportional relationships by looking at tables, an equation, or a graph. Glue this in on your IMN on page 28.